Yes, Yami. Okay. So I was here. Now what happens is, notice this information. I have, obviously row ID is not going to be important for me. What we're going to do is, for study hours, sleep and quiz, I have these three parameters. I have a input function over here, and I have an output which I get. This is again dependent on, over here I have W1, W2, W3. So I know for the first row, right? For the first row, you're studying for 12 hours. Here I'm sleeping for 6 hours and I got 78% in the quiz. Good question. I'm getting not visible. Sorry for that. Alrighty. Can you see my screen now? Okay. So what we're going to do here, we have this table over here. 12 hours of sleep, 6 hours, 12 hours studying, 6 hours sleep. In the quiz, you got 78%. These are my values. I know the output is 93%. I know the output is 93%. So what we do is we find out, let's say I assign some weights. I assign some random weights over here in terms of 2. We put this as 0.78 rather than 78%. Okay. This has 0.5 and I put this as again 1.5. So what I will get is some product. This get 40.17. So it should be 0.2. Yes, this is what I get based on these weights. In the same way, for the same weights, if I use the same weights, I'll have another neural network for this. 22, 6.5, 24%. Okay, 22, 6.24%, so 0.24. And in the exam, I get 0.68. Okay. Same way, I will create another neural network for this third one. 115, 4, and 1. Okay. Understanding what is happening over here?
Yes, sir.
Yes. So ultimately, the goal is to reduce this overall difference. You have this cost function, which is the summation of all of these elements. And the way it happens is there is a feedback sent from here. Based on this, a feedback is sent back to the beginning based on which this weight is changed. Okay. That is how it works. So when you look at this, here, what you look at it, you saw what we have done over here, right? You change this weights for each of these parameters. For each of them, you go on changing the weight to find out what is the best optimal information for each of them. And ultimately, what the purpose is going to be to reduce this summation, the overall cost function that you guessed, right? That is the purpose which is going to be. For all of them, then you again change W1, W2, W3. Understood?
So I have a question.
Yeah, man.
So, how does the first W1, W2, W3 come into picture?
That is random.
Acha, okay. And what if I want this thing to work the other way around? Here I know what my result should be. Like I know that my student should get 93%. But now I don't know. Like what if I don't know how much he scores and I have all other parameters? Then will it work?
That will be a different model only. It will not be ANN. This is your supervised learning. That will be unsupervised learning. So there will be a different process for that.
Okay.
It will work, but there will be a separate algorithm. I'm pretty sure about that.
So can you give us another example where this will work except for house and this study hours?
So it's like this was an example of regression. Okay. So if I want to, let's say, look at our data set earlier, which we had, right? We had, what data set we had for linear regression, multiple linear regression. Insurance price also, it can work for that. Car price. Here you can create a neural network using these elements, all these elements. Here you're predicting the price, right? So again, you can create a neural network using this information, artificial neural network, ANN. Understood? It's another way of, instead of using linear regression, multiple linear regression, or decision trees, or any other methodology for that matter, you can also use ANN for predicting or calculating the price. Understood? Make sense or no?
Yeah, little.
So here, right, I'll have these parameters as part of my inputs in the neural network. It's the same thing. Okay, here, when we had linear regression, we had y is equal to mx plus c. Right? Here, I have w1, w2, w3, and x1, x2, x3. Conceptually, I am still predicting a number, right? I'm still predicting a number over here in terms of 93%, 68%, 95%, which is why it is called ANN. In the same way over here also, we are predicting numbers. We are predicting, this is the house price that we have seen, what is the distance and stuff. So you would have tried this. If you have tried this, you would have tried it with multiple linear regression to find out what is the best model that you get, the optimal model that you get. Okay. What is the other? So any information. So here for these species, you want to predict the width or whatever that value might be, height or weight or width. That is where you'll use. Again, you can use this as part of a neural network, ANN. So again, there are different algorithms. This is one more algorithm in which you can find out the price of this particular, or the width of this particular what is species. Gives you some kind of an idea. You get some kind of an idea.
So,
Yeah.
so basically, we are training our model to give results which are closer to the correct ones. We are doing that only, no?
Yes.
So that the best model can come up, which is giving the results exactly what is desired, something like that.
Best model which covers all these elements, all these line items.
Okay, based on all these things, which can
Yes.
predict the output which is more near to the answer, the correct answer, something like that.
Yes. More close to this.
More close to
93,
the final result.
93%. So yeah, practically that is how it works.
The closer the more closer it is to the answer, it is good. It's the better the model is.
Yes.
Okay,
Yes.
so that the best one can be used on the unknown sets.
Yes, you want to reduce the error basically. This
Uh-huh.
error.
Basically, we are reducing the error. Okay. So the weights are changing just to reduce the error.
Yes, because you're
Okay.
trying to fit the model, right? The purpose of this
Hmm.
is to fit the model mathematically. It's
Yes.
like as a child, what was happening? You are shown a image of a apple. You
Hmm.
don't know what is for the first time. Then your parents tell you, okay, this is an apple. They again show it to you. You say, I don't remember. They'll again tell you this is an apple. Then that is what that process. You are getting a feedback from your parent. No, this is not correct. Okay. Or even if I look at it mathematically, when you were a kid, you were told to do the calculation of 9. Okay, 9 into 1, into whatever, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You were told to calculate this, right? So how did you do it? You counted it on your fingers. 9 into 1, 9. 9 into 2, 18. 9 into 3, 27. You used to do that. Then you suddenly made a mistake and you say 9 into 4 is 35, which is not correct. So at this point of time, you are told that this is not correct. Somebody tells you this is not correct. So you again go back and check. Okay, no, it is 34. Then again somebody does no, this is still not correct. Okay, then it is 36. That is how it is working. You are getting a feedback from someone, that you are getting a feedback that this is not correct. You know the answer over here is 9 into this. You know this is the right answer. And what you are generating is a random number. If I say, okay, let's just take the random number. I'm taking this random number, by the way. You want to reduce this difference. I'm not doing the summing and stuff. We can do that also. We can even do that, by the way. Yes. So if I have this right answer over here, you see this difference becomes 0. Understanding? So the purpose is I reduce the error to the minimum. So I put this as 17. I put this as 26. Let's say I put this as 35. I put this as 45. I put this as 54. I put this as 63, 71, 82, 98. Okay, then what do you have? 101 and 108. So the purpose is to reduce this number. Why? It would indicate that that is the best fit model. Understood?
Yes. Sir, the model can also eliminate few categories if the weight is very less or insignificant.
Yeah, yes,
This can also happen, right?
yes. So there are other algorithms actually. There is an algorithm called as LDA, if I'm not mistaken, right? LDA. No, what was that? There is an algorithm for yeah, PCA rather. Yeah, principal component analysis. Yes. Okay, they help you reduce the number of variables. We had looked at dimensionality reduction. What they do, if you have 1,000 variables, it won't make sense for you to run those 1,000 variables, the data using 1,000 variables. It's going to take a hell of a long time to do that. Which is why you have other algorithms which help you reduce the overall
Okay, okay. Only the
variable.
important ones they'll get.
it'll group all of them into 10 variables rather than 1000. It'll group all of them into 10 variables.
And use all of them. Okay.
Yes, it'll use all of them, but it'll reduce it to 10.
Use them.
That's
Okay.
what your PCA and I think LDA do that. Understood?
Yes.
So this was your ANN, artificial neural network. Now we want to look at CNN. Do you see what photo do you see over here? Do you see what uh, what do you see? Do you see a tree? Anything else do you see?
Yes, a tiger and a monkey.
Yes, a tiger and a monkey. Does everybody else see it?
So fishes are also there.
Yes, fishes are also there. What two images do you see over here?
A girl and a man with a mustache.
Old man. Yeah, you can see an old man with his face down. This is the girl on the left. What do you see over here?
A rabbit and a bird.
Yeah, on the right hand side, if you see it's like a rabbit. On the left hand side, it looks like a duck.
हाँ, duck.
Yes. What do you see? आंखें खराब हो गई? Yes. So here, what we are doing is a convolutional neural network. What you are doing is you are trying to predict whether this is a cheetah, whether this is a bullet train, and what that is. Right here, this is a bullet train. 80% chance this is a bullet train. 90% chance this is a cheetah. And here, this guess it as a scissor, but it is a hand glass. Okay, that is what you have CNN. In CNN, what you're giving is an input image, and what you're getting is an output. Obviously, you have labeled information. You're going to get whether that image is a cat or a dog or a whatnot. Okay, it can be anything. Categorical variable if it is more than one, binary variable if it is 0 and 1. Make sense? I am giving an image of a cat or a dog, and the output I'm going to find out whether that is a cat or a dog.
Yes.
Okay. So here, let's understand how CNN works. You see this? This is a smiling face, happy face. This is a sad face. If you give this, your output should be happy. If you give this, output should be sad. It depends on the features. What it does is, if you have a black and white image, it's going to be converted into pixels. So when I look at right, let's say I look at this paint. Have you ever opened you know, sometimes people send you an image of some random numbers and they tell you paste it in notepad and then you can see an image over there. Has anybody ever tried that? Anybody ever got that? Show you. When I look at this, right? Let's say I take a screenshot of this and I paste it over here. This is an image. You see, if I move my mouse on the left hand side over here, at the bottom left hand side over here, okay, just keep an eye on that. It is telling me what is the pixel location of each of these images. Underlying, if you ever open an image, let's say I save this image and desktop, it आ गया. Let's open it with notepad. You see, it looks like this. It's not really readable though. Okay, practically what it does, what you can do is you can convert each of these images into numbers over here. Can you make out the ones over here? So if I copy this, let's say I copy this into an Excel sheet over here. सही रखते हैं. Conditional formatting, highlight cells equal to 1. Highlight cells equal to 0 as custom format. We'll keep it as white. Do you see the smiley face? दिख रहा है क्या? Smiley face दिख रहा है आपको? If I remove the zeros, you see the smiley face now? Can you make out the smiley face? Right. That is what happens. Okay. So if it is a black and white image, it is a 2D array, 0 to 255 pixels. If it is a color image, you know RGB, right? Red, green, blue. If you don't know, you can set the color of any particular image using more colors. Custom this RGB value. I can change this RGB value over here, and I can change it in any way. That sets the color in that sense. That is why you see this RGB value. It will be a 3D array. Otherwise, if it is a black and white image, it's going to be a 2D array. Make sense? Clear till now? Alright. So what do you do first? You take this image and you put it into this format in terms of a binary number 0 and 1. There are 4 steps in CNN. Unlike your ANN, there are 4 steps in CNN. Here you have first step is convolution, second step is max pooling, third step is flattening, and fourth step is full connection. So we'll look at what it really means. Step 1, convolution. What do you mean by convolution? You have something called as feature detectors. You are trying to find out all the elements in this image, that you know that this eye is over here, this face is, the lips are over here, the nose is over here. Okay, you're trying to find out all those features, which is why you have this random feature detector. Okay, what we're going to do in this feature detector is we're going to take this feature detector and move it over each of these points. Output what you're going to get is a feature map. Okay, so what do I do first? You know, 0 1 0 0 0 0. So when I look at it, when I multiply this, right, 0 into 0 0 0 into 0 0. So here each of these points I'm going to put it on top of it and multiply all those elements. Understanding? Making sense? Yes or no?
So, feature detector is a separate matrix altogether. It's not what is there in the image input.
Yes, it's separate.
So all feature detectors will be like this only, or they will be different.
It can be different. It can be 100, 010, 000. It depends on how many feature detectors you use. So in the example that we'll see, there we are going to put the input as 32 feature detectors.
Okay.
You can have multiple of these feature detectors, how many ever you want. Okay. So you understood? I put this on top of this, right? I put this feature detector on top of this. I will get a particular output, 0. Then I move it over here. You notice this one and this one will give me an output, because of which is I'm getting an output of 1. Then again I do this. I keep on doing it like this.
Sir,
Ultimately,
can you
yes.
explain how we are getting the output once more?
Yes. So here, let's say I take this value. I'm going to copy this in Excel. Do this. What I'm going to do, I'm going to do this into this. So somewhere. to fix this. What do I do? I will stride it over. Right. You notice I'm striding it over like this. Bring it. Now again, if I go down, moves it down. Do you see it? Do you see the values moving? That is what I'm doing. First, I started from here. Okay. First started from this left hand corner. So I move this element which I have. Paste it like this. I put it on top of this. Okay, let's change the color for this matter. Okay, then I move it on top of this. 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 Make sense what I'm doing? And I'm doing a sum product. Yeah, then I go to the next line. Then over here I keep on striding it like this. Keep on striding it like this. Keep on striding it like this. Till I reach here. And I can see another output over here. This is my feature map. This is for one feature I am getting over here. Okay. Like this, I can have multiple feature maps. That is what you have a convolutional layer. I can have multiple feature maps. Alright, clear till now? You understood what the feature map does? Yes or no? Clear?
Yes. Um, Sir, the different layers, how are they going to be different from each other? Convolution layers.
Feature map
So
will
this I
different.
understood how to get the feature map.
This feature map will be different. Based on this feature map, you have these different layers.
Okay.
Ultimately, you what we'll see that one is this obviously for each feature map this is one convolution layer, right? On top of this again you can add another layer on top of this. It's like from one neuron you go to the other neuron. This output again you can go and again add another feature map, extract some feature map from this. So I'll show you an example, by the way. Let's see an example what it happens. Give me a second. This is a very complicated area, but okay, what it does, I'm going to add a number over here. I'm going to draw a number over here. Okay, let's say I draw a number. You notice what is happening? 5. It reduces 5, it goes on till here, and it shows you the final output. It is going to guess the number. By the way, better one, by the way. Yeah, this is a better one to explain. So I draw 5 over here. You notice what is happening? It's extracting these features from here, each of these points. It's going on reducing that. Each of these is a layer. By layer, going on adding that. Ultimately, you are guessing the value as 5. From here, you get till this point. That is what is happening in a neural network, by the way. Clear to a certain extent? If I make this as 6, it's guessing it as 5, 6 ही guess कर रहा है. See, this is guessing it as 7. Let's say 1, 1 है, 0. तो वो 0 guess कर रहा है इधर. Okay, whatever I'm drawing, right? It's getting it. It's guessing that value as 0 or 1. Get some idea? Yes or no? We'll see that. I'll explain it to you with one more example. Actually, I can show it to you here also. This is a value which is given as 7. दिख रहा है आपको इधर 7 दिख रहा है? Do you see this 7?
Yes, sir.
Yes. So when I put this layer as 7, I add this filter. This is your feature map. When I get that, I get some feature over here of this 7 का top है, ये है. Then I get the right hand side of this 7. In the second convolution layer, I add another filter over here. And again, what happens is, as you start using more convolution layer, this image size goes on reducing. Okay, this image size is reducing. If you notice, this image size was 28 by 28 over here. This, it has become whatever. कितना है? 26 by 26. Okay. Then this will become, I think, 24, 25, 24 by 24 होना चाहिए. जो भी है 25 by 24. Okay, it's going on reducing size by size, but I am still maintaining this feature. Understanding? I got this 7. I still am able to see that this is a 7. Understood?
Yes, sir.
So I know this will be little tough if you're seeing it for the first time, because it was very tough for me also when I learned it for the first time. Okay. There are, so here, right, this is gives you an example of what are features. You want to sharpen the image. You know, anybody who has worked on working with Photoshop or anything, right? If you want to sharpen the image, you use this filter. If you want to blur the image, if you use this filter, right, the image will become blurred. If you want to enhance the edges, you can see only the edges. So it becomes, if you use this filter, the edge will get enhanced. Make sense? You want to emboss, you use this filter.
Yes, sir. Understood.
Right? Then there is something called as depth. It corresponds to the number of filters you use for the convolutional operation. Okay, how many filters are you going to use? If you use 3 filters over here, the depth is called as 3. The stride is by how many number of pixels we want to slide. So we looked at this, right? Over here we were sliding. We were sliding this by 1. That is what is called as a stride. I am moving this by 1 cell. It is called as a stride. Understood? If I move it by 2, the stride will be 2. So instead of here, if I directly go to this column F, my stride is 2. Then again I move it to by 2. That is my stride. Understood? So if you use a larger stride, you might lose out on some of the features. Okay, suddenly if I start using 4 strides, I'll have this, and then I have this, then gone. I have lost quite a lot of information over here. Make sense? That is what is stride. So we had looked at this 6 by 6 image, one filter. So I move it this way. This is one stride. Okay, by each of them I am moving. Understood? You've taken the image, converted it into zeros and ones, and then you are doing a convolution layer. Now you have your activation function. Again over here you also have activation function. Mostly people use ReLU. This was your activation function. You give 0, you get 0. If you give 1, you get 1. If you give 2, you get 2. So y is equal to x for any value greater than 0. So here I have an original black and white image. If I put black is negative, white is positive. So I'll get only the white values. Because the black becomes 0, I get only the white values because they are positive. Makes sense? So I can see only the whites images. Yeah. So this is after applying ReLU, you get this. Only non-negative values. Only the positive values you will get. Understood? Yes, clear till now? What we did, we applied ReLU. Clear? Yes or no? The third step is called as max pooling. Okay, you have a lot of images. You'll have a lot of images, but what you have to do is you should be able to analyze or predict any image which might be given to you in any format or structure, which is why you do max pooling. Okay, your image can be rotated, your image can be squeezed, but still you can make out this is a cheetah, right? Can you make this out? For each of the 3 images you can make out it's a cheetah. And for each of them the cheetah is sitting, running, standing. So you need quite a lot of images from that perspective, which is why you do max pooling. What you do is you extract specific features from here. You take the maximum of these elements over here. For each of these strides you take the maximum of those values. So max is 1. So here max is 4, max is 2, max is 1. Here max is 0, max is 1, 2, and max is 1. You have a pooled feature list. So again what you're doing is maintaining the feature list, but you are still maintaining all those elements over here. Okay. One second. Understand what happened over here? So here when I look at this, when I do the max pooling, I still see the feature. I can still make out this 7, right? You can still make out the 7. Yes or no? Yeah. That is what is called as max pooling. You are ultimately reducing the size of the image. You're trying to reduce the size of the image to predict the right value in a way. Okay, this helps. This reduces the size by 75%, but it still maintains the features. You have average pooling, sum pooling, so you can sum all the values, you can average all the values. There are other techniques as well. So you have convolution, you have max pooling. You have the input, you have feature extraction, you have a convolution layer, and you have pooling. And finally what you get is flattening. So how much ever data you have, right, you just flatten it like this. So in the end, which you see over here, you have flattened the data like this. For each of these elements we have flattened the data. समझ रहे हो? I have just whatever max output I get, right, I have just flattened the value. So when you have this flattening, this is what you give as input to your neural network. Understood? I flatten this and then I give it to my neural network, which is my independent variables. This flattened output is my independent variable, which I give it to the neural network, and it will tell me whether this is A or B, a cat or a dog. Getting it? Understood the steps?
So I understood the steps, but I just have one question. Is that now this after flattening, say I had a picture of a dog and now flattening is done and I've got it in the straight column. So then what will be my x1, x2, x3 if it is just a picture of a dog?
Picture has to be converted into pixels. That is what I said. The first step is the picture has to be
Yeah.
converted into pixels. So your cat and dog will be converted like this. So your features, right? Your features will be that okay, a dog has a tail, a cat also has a tail. The dog's eyes are like this, the cat's dog's eyes are different. Okay, that is what you're creating. You are creating features for this. Ultimately, these independent variables, what you have is going to be the size. Uh, uh, each of these points which you see, right? 1 minute. Huh? Each of these points which you see is a specific feature that you're getting. You're maintaining this.
Okay,
That
okay.
it's just telling you that this 4 over here, right? When you flatten this in this way, when you flatten it and give it, right, this 0 0 0, then 0 0 0, then 0 1 3 3. So you'll know that when it is a 7, this value will be there over here around this point, around this point. Understanding? When you flatten it, right, it will become like this.
Yes, I understood.
Like the 15th point there will be a value in the 15th point, 16th point, or the 20th point. Like that, it is going to identify that 7, all the 7s has a number at this position somewhere. Understood? So we're going to go to Python. I had shared data with you. Okay, so this data is obviously this is there. You can use other data sets also. There is this data set of cats and dogs. What matters is how much training you do. Okay, how much, the more images you're going to give of different types of dogs, your neural network will be able to identify different kinds of dogs. Makes sense? There are 4,000 elements over here. There are 4,000 images of dogs over here. You see this 4,000 images of dogs, and there are 4,000 images of cats. Okay, clear till now? So this takes a long time to run. I had run this yesterday, though it is pretty simple. The number of steps are not many. We'll try and replicate these steps. So first of all, we're going to use TensorFlow. I don't think we've used TensorFlow before this. So if you want to know more about TensorFlow, we can definitely, what we do is we'll go to TensorFlow.
So, so I
Yes,
was
ma'am.
not able to open that data file in my computer. I don't know why it was not opening.
Let me try and upload it again. Arpita, were you able to download it again and check? Hello? Is Arpita there? Arpita, you there? One second. Wait. Give me a minute. Okay, it'll upload. Hopefully it'll upload. Then I'll explain the code. Okay. We're trying to see what is TensorFlow. We use two particular libraries, TensorFlow and Keras. I will send this code, by the way. I will copy this code as well over there. Try this. So notice over here. So I'm just going to run through this code. By the way, I will not run it again because I had already run it yesterday, and it does take long time depending on your PC. Right? It took 2 hours for this to almost run because it's in that sense. So first of all, I have my training data set. Okay. So I have an option of Keras called as image data generator. So if I go to Keras, so again, like we had seen earlier, let's go to Keras. We will remember we had seen sklearn, scikit-learn. It's not uploading, right? Is it uploading? I'm not able to see this one. So in Keras, image, data generator, image, data processing, not pre-processing. Hello, Crow. The Crow wants to learn. Yes, so Keras has this function of image data generator. Okay, there are a lot of arguments over here. So you remember we just talked about a specific aspect that you need images in this format. You know, the image should be rotated, zoomed. It can be zoomed out, zoomed in, rotated at an angle, or you use a shear in the sense like this. Okay, when I say shear, you're squeezing the image in that sense. So in a way, if I look at it right over here, if I go to Excel only, I insert a shape. Come here. This like a parallelogram, right? This is a square like this. In shear, I make it like this, you know, at a specific angle. It, that is what is called a shear. So here, okay, it's rhyming shear and here. One second, let me try and zip this again. By the way, okay, we are going to try and I'm going to explain the code to you now. I probably missed answering this question. We're going to try and explain the code. Just give me a minute. So you are rescaling this image by this value, 1 point by 255. That's like a standard most people use. The shear angle I explained, zoom range, obviously you can zoom it at whatever range, and horizontally flip. So when you say horizontally flip, if I have an image, I can actually flip it like this. Understood? This is a horizontal flip. I have an image like this. The crow is learning neural networks, so please pardon me for that. You see this flip horizontal, what happens? The image is like this. If I flip it horizontally, it becomes an inverted image. Okay, so you're training the data by augmenting your images in this way. Okay, that is what you're doing over here. One second, let me just. Any questions anybody has? you're doing a image data generator. Okay, you're generating. Now the next thing you have to do is you have to give your okay. This one mute only. All right. So I have this test data generator. Now what do I have to do? I have to take it from a specific directory. When I say directory, again over here when I go, I can actually see this example from directory. I have to give the path of my directory. First of all, I am using this training data set. I am giving a specific location. So understand one thing, when as of now in the way the code is written, okay, the way the code is written over here, the path it is taking is where my this Jupyter notebook code is present. Within that same location over here, okay, within that same location over here, I have my data set. So my code is over here, image processing. In that same location, I have my data set. Within that data set, I have a test set, I have a training set. That is how it is. Okay, that is how it has been structured. That is how this expectation is also there, because that is how it has been developed, that your data has to be at this particular location. It is the training data set, you give it in a particular folder. The validation data set, you give it in a particular folder. Make sense? Yes or no? Understood this aspect? Okay. Here the target size of the image, right, is 64 by 64. So when I look at an image, I look at one particular image, let's say in this training set of cats and dogs. If I edit it, look at the pixel size. Okay, the pixel size is 327 by 499. Look at another pixel size. You see it is a smaller image, 135 by 101. Ultimately what is going to happen, and let me show that to you also. Ultimately what is going to happen is, I think I have it. I'm not sure if I probably deleted it, I don't know. Should be here. Each of these images is reduced, by the way. Give me a second. These are resized images of the dogs. This is just to showcase to you, right? Many times that's what you do. I mean, ultimately that is what is happening. You see, this becomes so small, you can't even look at it. Understanding it, but you can still figure out this is a dog if you really put your mind to it in a way. But it's too small. Ultimately, that image is many times resize the image. The target image is 64 by 64 in our case. 20 by 28 pixel. Makes sense? don't move away, go away rather. And ultimately, if I look at it, like over here, right? And open by. This is a binary class because you're either predicting it is a cat or a dog. Class is binary because either you're predicting it is cat or a dog. If it is more than one value, it becomes categorical. That is what is mentioned over here. Tells me it found 8,000 images belonging to two classes. Because in my training set, there are two folders, each folder for your separate class. That is how it is structured. That is how you're supposed to structure your data. In the same way, for your for your testing purposes, for your validation purposes, you do not do all of this. You do not zoom it or change it. You just directly use the rescaled images. You do not enter flip or anything because that is not you're training the model using that. You are just validating the output, that is testing the model. And instead of training set, I am using test set, that is my output. Okay, now here after this you saw all the steps of CNN. You saw all the steps of CNN, right? We saw all the steps in terms of convolutional layer, max pooling. Then I can have another convolution layer. Then I flatten the this output, and then I use the activation layer. Yeah, I can use multiple activation layers over here. This is the first activation layer, and this is the final output which I have. Okay, that is the final output. That is my class. That is how it works. I'll just quickly talk about what this does. I know this is you are looking at it for the first time. It is going to be complicated because this is really a lot more technical as compared to your linear regression or any other algorithm that you might have looked at till now. When I look at TensorFlow, we are looking at tensorflow.keras.models. So here tensorflow.keras.model, right? That is what we are looking at. Models.sequential. So there you will get information related to this particular information. ये भी अटक गया. I'll come back to that, don't worry. So like I said, right, we are using X number of filters. We are using filters of 32. This kernel size 3 means when we had seen this 3 by 3, that is what was that is what is indicating my kernel size. The feature map size is 3 by 3. That is what it indicates. Like this. Okay. I'm using ReLU. My input shape is 64 by 64 by 3. I am adding that because it is RGB, which is why it is 3. Okay. Remember we had mentioned that it is going to be, if it is black and white, it will be 2D array, but it is not black and white, it is color. All the images are color, which is why you have 64 by 64 by 3. Understood this? Then I do max pooling. The pool size is 2 and the strides are 2. So here, you remember we had talked about max pooling. Where is it? Yes, max pooling. And we talked about strides in terms of how much. So here I am, instead of this, I am using 2 strides. That is the purpose of this particular code. Okay, of this particular code. Then I repeat this. The only difference between this convolution layer and the second convolution layer is I am not giving my input shape. My input shape is same as what I am getting above. That is the output of this, is my input to the next convolution layer. Finally, I flatten this. Okay, I am adding a activation layer ReLU, and I am adding another activation layer, which is giving me an output of 1. One output in terms of what is the final value. The metrics I am looking at is accuracy and the loss. There is a specific kind of loss mathematically again. Optimizer, again I am using Adam. You might not be aware of any of these elements, but just for now, think of it as values which you are passing to this particular function. Like we had in linear regression, you fit the model, right? Here you are fitting and generating, you are giving the training set, you are giving the validation set, you are giving a test set. Okay, you are using 25 epochs, and in each epoch you have 334 steps. So what we had seen, right, in terms of this particular process, we had seen this entire process, right? The weights, changing the weights every time you go and change the weight. So all those parameters are happening as part of this process. You notice it starts with 70% accuracy, validation accuracy. Then it goes to 73% accuracy, then 71, then 77. Ultimately, it has reached, in the final epoch, it has reached till 81% accuracy. Understood till now? I know it will be very difficult for you to understand, but I am just giving you an idea. Unless and until you don't try it, you might not really understand what is happening. You'll have to read about it a lot, get it for the first time, because this is very uh, much more technical as compared to your linear regression, or even for that matter your uh, logistic or any of the others. I think those were much simpler as compared to this. Clear? I have built this model. Okay, a CNN model has been built till this point. The code is very small, but the process that we explained is there in this. The process that we saw in the presentation is mentioned in this. If you are finding it very complicated, don't worry about it. Uh, you will get it. If you try, you will get it. Because each of these parameters has a meaning, each of these elements has a specific purpose. Okay. So I'll show you a simple example in terms of what is the way this works. The first step is I have an image. I convert this image into this target size. Okay, I am reading this image in terms of this single prediction. Download first. No, not here. There are 4 images. This is the image of a dog. You see this? The first image is of a dog. Yes, can we agree on that at least? कुत्ता दिख रहा है ये? So the expectation should be that my output should be a dog. So what I'm doing first, I am reading this image as a 64 by 64 image because my model is taking the image as 64 by 64. Okay, I've converted this image into an array. Actually, if you print the test image over here, we print करेंगे तो hopefully image बताएगा. Yeah, you see this image of the dog. This is the array. पूरा नहीं print किया है, but वो बता रहा है वैसा. Okay, I've converted that image into. Then I'm adding a third axis. Using this line, I'm adding a third axis. And finally, the CNN model that I created above CNN, its name as CNN. This CNN, right? That is the model I'm using. So I'm going to use CNN.predict and I'm giving the test image. So output, it tells me if I print this result, right? That if your result is cat 0, dog 1, that is what is going to tell me. If it is 1, the result is 1, the prediction is a dog. If the result is 0, it is a cat. So here it is telling me it is a dog. Because so if I remove this, if I run this again, see it is telling me it is a dog. If I change it to 2, it will tell me it is a cat. Because my second image is this is a cat. See, it is telling me it is a cat. If I give 3, so it did not predict one of them correctly. It did not, yesterday at least it did not. This is telling me it is a dog. 3 is a dog. 3 is a dog, that is correct. And 4 is a cat. Okay, सब correctly predict किया. Very good. Understood? What is CNN? Like I mentioned, it might be complicated, but it will give you a decent idea of what is happening. If I take another dog image from here randomly, if I take this image, and I predict for that 5, my input is the second, fifth image. It should give me as dog. Let's see what it gives. Yeah. Yeah, so this is printing it as cat, which is not correct. Okay, so this is an error, but the accuracy is 81%. Understood how CNN works? I am going to give you a link which you can try. It also explains it. You can try this link. This one. I'm I'm going to send you a link, by the way, that should help you step by step. I'll save it somewhere. Any questions? I know everybody's gone to sleep. It should help you to some extent. विशेष टिप्पणी. You guys there or? Hello. There is a delay in messages over here somehow. Yes. So my question was, you guys understood? CNN, CNN. Okay, it's complicated. Yes. The more you read it, the more you'll understand it. So any questions, any doubts related to the previous sessions or today's session? Any doubts, folks?